Okay, Ma, what we discussed in the previous session? Anyone can please respond? Can anyone please respond? We discussed in the previous session.
Ma'am, you told about pumping lemma, ma'am.
I have introduced the pumping lemma, right?
Yes, ma'am.
Yes. Okay, what is pumping lemma for CFL means? Pumping lemma is a technique or a tool which is used to prove the language is non-CFL, which is not a CFL. In that, the formal definition is let L is in any infinite context-free language and the string Z belongs to L. Here the condition is assume Z is equals to U, V, W, X, Y. Modulus of that is length of U, V, X less than or equals to length of Z. And Vx greater than or equals to 1. This is the formal definition of the pumping lemma. Now we'll see the example for this. We'll see the example for this. The given language L is equals to A power n, B power n, C power n, where n greater than or equals to 1 is non-CFL. We have to prove this given not a contest-free language. Okay, we have to prove that the given language is not a contest-free language. Dini manam prove cheyali by using the pumping lemma technique. Okay, by using the pumping lemma technique. What we discussed, Z belongs to L. So Z belongs to L means simply it is Z belongs to A power n, B power n, C power n. Okay. So is it in Z is equals to what we have seen according to the definition U, V, W, X, Y. But here you are having only 3 symbols. But what we are having as a Z, we are having 5 symbols. So how can we do that? Means simply I'm writing this A power n, n I'm assuming it like K, A power K, B power K, C power K. I can assume like A power K minus 1, A power K, B power K, epsilon, C power K. Why I have written like this means because as per the definition equals to U, V, W, X, Y. So I'm assuming this U, V, W, X, Y. Okay. So now the given language is in the form of Z, that is U, V, W, X, Y. Next, what is the first constraint? U, V, X less than or equals to Z. This is the first constraint. U, V, X less than or equals to Z. This is the first constraint. What is your U? What is your U?
A power k minus 1.
What is your V?
A power k minus.
What is your X?
C power. Yeah, epsilon.
Epsilon only, right? What is your Z? Simply overall. A power k minus 1, A power k, B power k, epsilon, C power k. So if you consider this, sorry, this is A power 1, ma, k minus 1 plus 1, it will become the 1, no? So it is 1. Okay, this will give you A power k. This will give you A power k, B power k, C power k. So if you observe the length, I am assuming my k value is equals to 2. Suppose I have assumed A power 2 less than or equals to A power 2, B power 2, C power 2, which means what it will give you. A power 2 means A square, B square, BB, C square, CC. What is the length of this AA? 2 less than or equals to what is the length here? 6. Is it true or false?
True, ma'am.
It is true. That is the first constraint. Next constraint is Vx greater than or equals to 1. Vx greater than or equals to 1. What is your V? V is nothing but A and X is nothing but epsilon. V is nothing but A, X is nothing but epsilon. Greater than or equals to 1. What is the length of this? Simply 1. 1 greater than or equals to 1. Equals to is there, no? So it is also true. If both the conditions are true, hence the given language is non-CFL. Got it, ma?
Yes, ma'am.
Now we'll see one more example and then we'll move on to the next module. Given that L is equals to WW, where W belongs to A plus B whole plus. What is the given language? WW. Okay, here simply I am assuming that W is equals to A power K, B power K. So what is the given language then? Language will be A power K, B power K. This is first W. Next W is again A power K, B power K. Z belongs to L. So what is your Z now? Z is equals to A power K, B power K, C power K and sorry, again A power K, B power K. How can you write this? Z is equals to U, V, W, X I am assuming like epsilon, X and Y, U, V, W, X, Y. First, what is the initial condition? U, V, X less than or equals to Z. What is U, V? U, V is A power K, B power K. What is your X? Simply it is epsilon less than or equals to A power K, B power K, C, A power K, B power K. Assume K is equals to 2. Here you will get A, B, B. Here you will get AA less than or equals to AA, BB, AA, BB. Here the length is 4, here the length is 8. Condition true. Condition true means what we can say, the first constraint is true. The next constraint is Vx greater than or equals to 1. B power K, X is epsilon greater than or equals to 1. Assume K is equals to 2. B square, which means BB. BB means the length is 2. 2 greater than or equals to 1. Condition true. Condition true means the given language is not a contest-free language.
Ma'am,
Yes, ma'am.
can't we consider y to be epsilon, ma'am, instead of x?
Yes, you can consider, ma, but it will be easy if we consider epsilon in between. Don't consider the first and last one. In between, you can consider. Anyway,
Okay,
you
ma'am.
can consider anywhere you can consider.
Okay, ma'am.
But generally, how can we do this means here U, V, W, X, Y means here V power I, X power I will be there. So generally we'll divide only this V and X parts. This is not mandatory, but actually the formula is U, V, W, X, Y. If you want to increment or decrement, the possibilities are V and X. Generally, that's why we'll consider V and X parts only. Okay.
Okay, ma'am. Thank you.
This is nothing but the pumping lemma. So with this topic, we have completed module number 3. In module number 3, we have seen what is a grammar, what is contest-free grammar, derivation trees, contest-free language. Next, simplification of contest-free grammar, which means removal of useless symbols, removal of unit productions, removal of epsilon productions. And then we have seen CNF and GNF, normal form and Reback normal form. Chomsky normal form is you are having either two variables or single terminal. In Reback normal form, it must start with the terminal. After that, you may have any number of variables or you may not have the variable. And then pumping lemma. I think I'm clear with this, right?
Yes, ma'am.
Yes, ma'am.
I'm moving forward, ma. This fourth module is, once I'll show you the syllabus. Is it visible, ma'am?
Yes, ma'am.
Definition of push-down automata, the language of push-down automata, equivalence between acceptance by empty stack, acceptance by final stack, equivalence of CFG and PDA, deterministic push-down automata, closure properties, and membership algorithm. These are the things we are having in this module 4. Okay, we'll see one by one. Today I'll introduce what is push-down automata, how it looks like, what are the necessary conditions to move from finite automata to push-down automata. All those things we'll see, and tomorrow we'll dig into the machine construction. Okay. So the next concept is completely push-down automata. Push-down automata, which is PDA. Push-down automata means, if you observe, do you remember the Chomsky hierarchy, ma? First one is regular languages. Second one is context-free languages. Third one is context-sensitive languages. Fourth one is recursively enumerable language. These are the things we are having in this Chomsky hierarchy. Here the machine is finite automata. Here the machine is push-down automata. Here the machine is linear bounded automata. Here the machine is Turing machine. These are the things we are having. So regular language and finite automata part we have completed. What is the necessary conditions, or why we have moved finite automata to context-free languages means finite automata can accept only the regular languages. Only the regular languages means, for example, here I'll tell you one example. Assume the given language is equals to a power n, b power n, where n greater than or equals to 1. Can we construct a finite automata for this language? All of you try it. Can we construct a finite automata for this language? Please think and respond. Can we construct a finite automata for this language? If you try this, then it will be easy for you to understand what is push-down automata, why we have moved. These things you'll get a clear crystal clarity. Seema, please respond whether is it possible to construct a finite automata? No. Why it is no? For example, we'll consider the given string is equals to n. I am considering as 2. AABB. Only it has to accept AABB. So how can we construct the finite automata AABB? Okay, suppose my n value I have changed it to 3. So what you have to do again, it has to accept AAA. So one machine cannot able to construct this A power n, B power n values. One machine cannot able to construct this A power n and B power n values. So suppose the given language is equals to A power m, B power n, m greater than or equals to 1. Can we able to construct the machine for this finite automata? Can we construct the finite automata for this language A power m, B power n?
Ma'am, can you repeat the previous statement that you told?
First tell me, man, again we'll move on to the previous problem. Can we construct the finite automata for this language A power m, B power n?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Can we construct? Assume m is equals to some value and n is equals to some value. So greater than or equals to 1 means it may have either A. After this, you may have any number of A's. Is it not? Any number of A's. Or it may start with B. After that, you may have any number of B's. Right? Any number of B's. So we can able to construct the finite automata for m comma n greater than or equals to 1. Why here we cannot able to construct the context free language or finite automata? Sorry, why we cannot able to construct the regular language or finite automata for this example? Why we can able to construct here? Why we cannot able to construct here? Because here m is different and n is different. M is separate variable, n is separate variable. There is no restriction that the number of A should be similar with number of B's. Alanti count, alanti criteria aim ledu, because m and n are two different variables. But when you come to this language, if n is equals to 2 means 2 A's, 2 B's. If n is equals to 3 means 3 A's, 3 B's. Here, the number of A's should be equal to number of B's. Are you following, ma? Here, number of A's should be is equals to number of B's. So, every time we have to count. Where will you count? Here, no count is required. Simply m is different, n is different. But when you come to the above example, this one, here the number of A's and number of B's should be same. Should be same means, suppose if there are 10 A's, you should count the B's also, that there should be 10 B's only. So here you require count. With the finite automata, we cannot able to count the things. So this is not possible through finite automata. These conditions make us to create the push down automata. Push down automata ante nothing but it is simply a finite automata plus one stack. Finite automata plus one stack is equals to push down automata. Finite automata plus one stack is equals to push down automata. So finite automata means same like this we will construct, but here the restriction is there should be equal number of A's and equal number of B's. That will be calculated by this stack. Am I clear with this?
Yes, ma'am.
Stack to ela count chestaru ma'am అని మీకు డౌట్ రావచ్చు. For example, observe here, a power n, b power n, sum n is equals to 3. I am assuming 3. If I assume 3 A's and 3 B's, I'll get. So how can we construct means, when I construct A, when I encounter the input symbol A, I'll push into the stack. When I encounter A, I'll push into the stack. Yes. Next symbol. This is also A. A ante push cheyala pop cheyala ippudu nenu?
Push, ma'am.
Push. Again A. Can I push or pop?
Push.
Push. Again B. B ఉన్నప్పుడు నేను pop చేయాలనుకుంటున్నా. Pop means first A will be out of the stack. I'll remove the A from the stack. Again B. Push or pop?
Pop.
Pop. Again B. Push or pop?
Pop, ma'am.
Pop. Now, what you are having in your stack?
Empty stack.
Empty stack. So, when you encounter or when you see empty stack means here the number of A's and number of B's are equal. అర్థమైందమ్మా? పుష్ డౌన్ ఆటోమేటాకి ఎందుకు వెళ్ళాము? ఫైనైట్ ఆటోమేటా ద్వారా మనం ఏం చేయగలం? జస్ట్ వీ కెన్ ఏబుల్ టు కన్స్ట్రక్ట్ ద మెషిన్, బట్ వీ కెనాట్ ఏబుల్ టు సాటిస్ఫై constraint A power n, B power n. So here the constraint is A's and B's should be same. ఈ constraint ని మనం ఏంటి ఫైనైట్ ఆటోమేటా ద్వారా సాటిస్ఫై చేయలేకపోతున్నాం. మరి పుష్ డౌన్ ఆటోమేటా ద్వారా ఎలా సాటిస్ఫై చేస్తున్నాం మీన్స్, పుష్ డౌన్ ఆటోమేటా is nothing but finite automata plus one stack. That stack is going to count the number of A's and number of B's. Suppose for example n is equals to 3 అనుంది, బట్ నా దగ్గర గివెన్ స్ట్రింగ్ లో 4 A's and 3 B's ఉన్నాయి అనుకుందాం. ఫస్ట్ A, will you push or pop?
Push, ma'am.
Second A.
Push.
Third A. A. Push. Right? First B.
Pop.
Second B. Pop. Third B. Pop. Now is the stack empty?
No, ma'am.
No, ma'am.
No. Now, suppose here the is a power n and b power n, where number of a is greater than, number of a is greater than number of b's. Adena nenu construct chesindi. Can we able to construct this push down automata for this?
Yes, ma'am.
Yes or no? Empty stack వస్తే ఏంటది ఇప్పుడు యాక్సెప్ట్ అయిందా?
No, ma'am.
No. So though one stack is not able to construct the finite automata, if you add one more restriction. This is nothing but the simple introduction about push down automata. Push down automata ante entante the language which are accepted by finite automata, in the language which are not accepted by finite automata, we are adding one stack to the finite automata to make the language to be accepted by some other machine. That machine I have given the name as push down automata. Finite automata 1 plus 1 stack is nothing but the push. I think I'm clear with this introduction. Now we'll move on to the formal definition. అసలు ఎందుకు మూవ్ అయ్యామో మీకు క్లారిటీ వచ్చిందా?
Yes, ma'am.
All of you, please respond.
Yes, ma'am.
Okay, now we'll move on to the push down automata. The mathematical representation of CFL is called as push down automata, and this push down automata is 7 tuple. Generally 5 tuple enti number of states, number of input symbols, and then transition function. Before the transition function, symbols, that is tau, z naught, and remaining are common, delta, q naught, f. What all these things we'll see now. This q is nothing but the set of states. The sigma is nothing but the of input symbols. What is this tau means? Here it is if you have q sigma delta q naught f means simply it is a finite automata. But here push down automata means finite automata plus one stack. Stack means stack symbols of need, right? So tau is nothing but the set of stack symbols. Are you following, ma? What is tau represents? ఇక్కడ ఒక మనకి extra parameter add అయింది కాబట్టి ఈ two terms is going to represent this extra parameter. So tau represents set of stack symbols. Am I clear with this?
Yes, ma'am.
Next, z naught represent top of the stack. Who is lying on the top side? Top of the stack. Delta is nothing but the transition function. Delta is the transition function. Q naught is the initial state. F is the final state. I think I'm clear with this, right?
Yes, ma'am.
Okay, the mathematical representation of the push down automata or CFL is a 5 tuple, where the 5 tuple is m is equals to q comma sigma comma tau comma z naught comma delta comma q naught comma f. Q represents the set of states, sigma represents the set of input alphabets, tau represents the set of stack symbols, z naught represents the top of the stack, delta represents the transition function, q naught is the initial state, and f is the final state. Some basic points about the push down automata is push down automata is nothing but finite automata plus one stack. ఈ finite automata లో కూడా you can use epsilon NFA. Epsilon NFA plus one stack is nothing but the push down automata. Okay. Epsilon NFA means which means epsilon transitions are allowed in the push down automata. This is the basic definition of push down automata. So how can we represent this PDA? How can we represent this PDA? Okay, that means the transition. Here I'm going to represent the transition. The moment of PDA is defined by I would depends on 3 symbols. Ante enti? Earlier, how many symbols in finite automata? The state and the input symbol. Avuna Q0 on A is going to Q1. Ikkada enti Q0 on A. Any symbols unnai ikkada? It depends on 2 parameters. What are they? Current state plus input alphabet. Intena manam finite automata lo chusindi inkemanna unda? ఇంతనే మనం చూసింది ఫైనైట్ ఆటోమేటాలో అమ్మ ఫైనైట్ ఆటోమేటాలో Q0 on A is going to Q1. Q0 on A means current state and the input symbol is going to some other state. This is the thing what we have seen earlier in the finite. When you come to this push down automata, this PDA depends on 3 symbols. How many symbols can anyone guess, ma? 3 symbols. What are they? Can anyone able to guess?
Star plus and
Same current state, current input alphabet. ఈ రెండు కామన్ ప్లస్ 1 స్టాక్ అన్నాను చూసారా స్టాక్ కి టాప్ మోస్ట్ సింబల్ ప్రెసెంట్ ఏముంది దాన్నే కదా మనం పాప్ ఆర్ పుష్ చేస్తున్నాము కరెంట్ టాప్ మోస్ట్ సింబల్. Am I clear, ma? This PDA movement depends on 3 symbols. Identi finite automata movement. Now I am talking about PDA movement. Push automata movement depends on 3 symbols. Current state, current input symbol and current topmost symbol. I think I'm clear with this, right? Okay, I'll show you the example. Suppose assume the given string is equals to ABA. General ga deeniki finite automata cheppandi. Q0 on A is going to Q1, Q1 on B is going to Q2, Q2 on A is going to Q3. Generally, we will construct like this. So Q0 on A is going to Q1. So it depends on the current input symbol and state. Now, when you come to same string, when you consider in the push down automata, it depends on how many symbols?
3.
3. What is the Q0? Input symbol is A and topmost symbol. What is the top of the stack? A symbol to represent chestam initial ga top of the stack ni.
Z0, ma'am.
So initial ga stack lo em untadi Z0 untadi. Z0 represents it doesn't have any input symbol. Simply it is like empty stack. Empty stack ani ivvakunda manam direct ga empty stack Z0 to represent chestam. Always the topmost symbol initially is Z0. So topmost symbol is Z0. Is anybody having doubt regarding this transition? Is anybody having doubt, ma? Yes, somebody has raised your hand. Any doubt, ma?
Ma'am, can
No,
you
ma'am.
repeat?
Nothing, ma. Earlier delta, how can you write simply delta of Q0 on A is giving you some Q1, something else you'll write, right? Same here, earlier it is state and input symbol. When you come to this push down automata state, input symbol, along with these two, we are having one more that is top of the stack. Top of the stack is always Z0 untadi manaki stack lo. Top of the stack is Z0 initially. Nalini, ardhamainda?
Yes, ma'am.
Now, this Q0 will go to some Q1 assume. Okay, Q1 assume it will go to some Q1 and the input will be transformed to something. అంటే నెక్స్ట్ ఇన్పుట్ సింబల్ ఏదో ఒకటి ఉంటుంది కదా దాన్ని నేను సింపుల్ గా ఎక్స్ అనుకుంటున్నాను. వెన్ ఐ ఎన్కౌంటర్ ఏ ఐఎమ్ పుషింగ్ ఎక్స్ ఇన్ టు ద స్టాక్ అండ్ ఆల్రెడీ స్టాక్ లో ఏముంది మనకి Z0 ఉంది. ఇది ఎలా రాసిన అర్థమైందమ్మా? It is going to some other state, that state number taking it like Q1 and A place A వచ్చినప్పుడల్లా నేను ఏం పుష్ చేస్తున్నాను X అనే వేరియబుల్ ని పుష్ చేస్తున్నాను. ఐఎమ్ జస్ట్ అస్యూమింగ్ కి X. సో A ని నేను X గా ట్రాన్స్ఫార్మ్ చేశాను. Next Z0 is already available in the stack. Am I clear with this?
Ma'am? Ma'am, when we're pushing this into the stack, ma'am, first we're considering Z naught, then we start with A, then B and A, ma'am. Or we
is ABA. First we are starting with A. A is giving you Q naught X Z naught. Suppose I want to next is Q1 on, next input symbol is B. What is the top of the stack now?
B, ma'am.
Top of the stack. I'm not asking the input symbol. Top of the stack. Stack lo ఏముంది top symbol?
A, ma'am.
Stack లో ఏముందమ్మా? ఏ ఉందా X ఉందా?
Ma'am, A, B, A, no, ma'am. Okay, X, ma'am.
X, right? When you encounter B means A ante push అనుకున్నాం, B ante pop అనుకున్నాం. When you encounter B, okay, simply it is going to some other state Q naught and B వచ్చింది. B వస్తే మీరు ఏం చేయాలి? పుష్ చేస్తారా, పాప్ చేస్తారా? ఏ అంటే పుష్ అనుకున్నాం, బి అంటే పాప్ అనుకున్నాం. ఇప్పుడు పుష్ చేస్తారా, పాప్ చేస్తారా?
Pop, ma'am.
సింప్లీ ఐఎమ్ పాపింగ్ దిస్. పాప్ చేస్తే నాకు రిమైనింగ్ ఏం మిగిలింది? మళ్ళీ ఓన్లీ జెడ్ నాట్ మిగిలింది. నెక్స్ట్ సింబల్ ఏంటి? డెల్టా ఆఫ్ క్యూ టు నెక్స్ట్ ఇన్పుట్ సింబల్ ఈజ్ ఏ కామా జెడ్ నాట్. ఏ కామా జెడ్ నాట్ అంటే ఆల్రెడీ మనం చేసాము. సమ్ అదర్ స్టేట్ విచ్ ఇస్ Q3 ఏ జెడ్ నాట్ ఇస్ ద స్టాక్. ఏ కాస్త ఎలా మారుతుంది? ఎక్స్ గా మారుతుంది. నౌ జెడ్ నాట్ ఇస్ ఆల్రెడీ దేర్, ఎక్స్. Is the stack empty? No. So this is not accepted. ఇలా మనం చేస్తాం. అర్థమైందమ్మా?
Yes, ma'am.
I think I'm clear with this, right? See, I did not tell you any example. Simply my intention is how it is transforming. If you are pushing, push that symbol. If you are pushing means A ni నేను పుష్ చేస్తున్నా, దాన్ని నేను X తో రిప్లేస్ చేశాను. B ని నేను ఏం చేస్తున్నా? పాప్ చేస్తున్నా. పాప్ వచ్చినప్పుడు దీని నుంచి పాప్ చేసేస్తాం. పాప్ చేస్తే రిమైనింగ్ ఏం మిగిలింది? ఓన్లీ జెడ్ నాటే మిగిలింది. అర్థమైందా? ఈ ఏ ప్లేస్ లో కూడా మేడం ఏ జెడ్ నాటే రాయొచ్చు కదా అని మీకు డౌట్ రావచ్చు. Why I did not use means a did not, because if you want you can write it, ma, but according to the context free language generally we will represent these terminal with variables only. అంటే మనం ఏమని రాస్తాం? x ని a గా ఇలా రాసుకుంటాం కదా, జస్ట్ అలాగా నేను a ని x గా ట్రాన్స్ఫార్మ్ చేశాను, అంతే. నథింగ్ చేంజ్. I think now is it clear how the transition occurs? Transition depends on three symbols, ma. Input symbol assume, state assume it is Qi. Input symbol assume some input symbol A, and top of the stack assume it is Z naught. If you are doing push operation, what you are pushing in place of A? I'm going to push X in place of A. Already what is available in your stack? Already Z naught is available. How it is transforming? Suppose Qi will be transformed like Qj. This is the only intention of transition. It is the only intention of mine to represent the transition function. If you understand this, then we can able to construct the machine. Is it clear, ma? Is it clear? Say yes or no. Sharad?
Yes, ma'am.
Yes, ma'am.
Okay. Nalini, అర్థమైందమ్మా?
Yes, ma'am.
Okay. This is nothing but the push down automata. Push down automata is a 7 tuple. The remaining 5 tuples of finite automata is common. The extra 2 tuples are, first one is tau. Tau represents stack symbols. Stack symbols అంటే ఇప్పుడు నేను మీకు చెప్పాను కదా, జెడ్ నాట్, ఎక్స్, సపోజ్ బి వచ్చిందంటే వై అనో సంథింగ్ ఏది పుష్ చేస్తే those are called as the stack symbols, and z naught is the topmost symbol of the stack. Any doubts regarding this? Please let me know your doubts. If you understand this transition function, then only we can able to construct the push down automata. If you are clear with this, then we'll move on to the language and we can able to construct the automata. Okay, ma, clear here. When will you accept this? Push down automata means the acceptance can be done through acceptance by empty stack and acceptance by final state. If it reaches to final state, then also we can accept. If it reaches to empty stack, then also we can accept. Earlier in finite automata, we can accept only through final state, but here we are having one more extra parameter, that is stack. No, so you can accept the language whether it is accepted by finite automata or whether it is accepted by empty stack. Conditions, you can say that it is a context free language or it can be accepted through push down automata. Am I clear with this, ma?
Yes, ma'am.
Okay, in the next session we'll see the problems of this push down automata. If you have any doubt, please raise your voice. Any doubts, please raise your voice, ma. Those who are having doubts, they can stay, and remaining people can leave this session.